To serve as an introduction to logarithms. And what a logarithm is, it's actually just another way of writing an exponent, and they're inverses of each other. Like addition is the inverse of subtraction, multiplication inverse of division, square and square root are inverses of each other, they undo each other. Logarithms and exponentials also are inverses. You could use an exponential to undo a log or a logarithm to undo an exponential. And the relationship between the two, I have them here in color. The base of the exponent is going to be the same as the base of the log. The exponent in the exponential equation actually turns into the answer with a logarithm, and the answer to an exponential is the argument or inside the log. And it's a little confusing until you do them. Here's the way I like to remember it. Log, base, answer equals exponent. So say I have log base 2, 8 equals x. I can rewrite this as an exponential. 2 is my base, x is my exponent, and 8 is my answer. Let me show you some examples. So here we have rewrite each equation in logarithmic form. So we're going to turn it into log base answer equals exponent. So I'm going to start off with log. The base of the log is going to be the same as the base of the exponential, b. Log base answer. Answer is a, and it's going to equal the exponent, negative 20 over 11. So for number 2, rewrite that as a log. Write that as a logarithm. All right, I'm going to go ahead and do it. I have log base 12 answer x equals exponent y. And you can also go the other way. For 3 and 4, you're given a log and you're asked to write that in exponential form. And it's going to be the same thing. It's log base answer equals exponent. So my base is going to be the same base as an exponent. The exponent is negative 9, and the answer is, whoops, that's supposed to be a b. Base, answer, exponent. So do the same for number 4. So I was going to follow this circular pattern. The base of the log will be the base of the exponent. The answer of the log is going to be the exponent. And what's inside the logarithm is going to be your answer. So we do more than just rewrite. And what a logarithm means, if I'm looking at these number 5 and 6, it means 7 to what power is going to give me 1 over 343. This evaluates down to some number. 7 to some power equals 1 over 343. And if you have your degree chart for exponentials with the different numbers to the different powers, all this will simplify down into negative 3. 7 to the negative third power equals 1 over 343. So this log base 7 of 1 over 343 just evaluates down into one number, negative 3. Number 6 is asking 4 to what power equals 64. And this will all evaluate down into some number. 4 to what power gives you 64? And the correct answer is 3. 4 to the third is 64. So it all evaluates down into one number. Last thing I have to show you is using a calculator. I'll show you number 8 because your calculator, it'll do two types of logarithms. It'll do log, and then it has another one, it's ln for natural log. Those are the only two that you have buttons for. So if you want to evaluate log of 1.8 in your calculator, do that. Log 1.8, enter. And I get approximately 0.2553. But like number 7, you're often given a logarithm with a base that doesn't show up in your calculator. When you're given, like number 8, a logarithm with no base, it means base 10. When you're given something other than a base 10 and asked to evaluate in the calculator, you're going to have to do this thing. It's called the change of base formula. And what you're going to do is you're going to do the log of the larger number and divide that by log of the base. Log of 6.8 divided by log of 7. Let's see, log of 6.8 on the top divided by log of 7 on the bottom, and I get about 0.9851. All right, there's a handout with this. Good luck with this today.